Good morning, Honors Geometry. All right, so you don't have bell work today, but I wanted to start off the lesson with this bell work because I think it leads very naturally into what I'm going to talk to you about in this video. Okay, so this video is about justification, and justification is basically evidence. So think about these following situations. So let's say you wanted to prove that a student read the book To Kill a Mockingbird. How would you prove it? Well, you might say, if I give them a quiz or a test on it and they get 85% of the questions correct, then that's proof that they've actually read it. Maybe if they write a book report on it and accurately describe the plot line, that means that they've read it, something like that. Okay? What about if you're trying to prove that an employee worked 10 hours last week? Maybe time cards, some type of punch in, punch out kind of system, something like that. What if we're trying to prove that the average height of one basketball team is greater than another? Again, we could do some calculations, right? We could explain, well, okay, so I can take this team over here, calculate all their heights, and then average them. Take the other team, measure their heights, calculate the average there, and then I could compare them. Okay, so the idea behind this is that there's a lot of statements we can make in life and in mathematics as well that you can say the statement, but you have to have something to back it up in order to prove it or say why it's true. And all of these things would be considered evidence, or the word that I'm going to use today is justification. Okay? All right, so just so you know what you're looking for as we go through this lesson, we need to be able to use definitions, properties, and theorems to justify a statement. So in the previous slide on the bell work, we were using just, like everyday things like time cards and measurements of heights and stuff like that to justify things. In geometry, whenever we have a geometric statement that needs to be justified, we're going to use definitions, properties, and theorems. Okay? So you should have a piece of paper, or actually a packet, that looks something like this on the front page. Okay, so let me go ahead and read through the first part of this with you. Okay, so it says a proof is an argument, a justification, or a reason that something is true. A proof is an answer to the question why when the person asking wants an argument that is indisputable. Okay, so in the future I'm going to start asking you questions like what is proof, why do we do proof, and your answer is to answer the question why. Okay, because in the high school geometry setting, we now no longer just accept things as true. We want to know why they're true. That way we can see, oh, okay, this actually has some basis in fact. Okay. There are 3 basic requirements for constructing a good proof: awareness and knowledge of the definitions and terms related to what you are trying to prove, knowledge and understanding of postulates and previously proven theorems related to what you are trying to prove, and knowledge of the basic rules of logic. Okay, you've actually got a good handle on the basic rules of logic after Unit 1. After Unit 1, you've got a fairly good handle on lots of definitions, and we'll continue adding to the list of definitions that you need. And then we're going to continue to learn postulates and theorems. Now, what this should mean to you is that as we go through our lessons, make sure you're catching on to all of the definitions and all of the theorems. If anything ever doesn't make sense, please ask, okay? Because we might be needing to use that in a future proof. To write a proof, you must be able to justify statements. The statements in example A are based on the diagram to the right, in which lines AC, EG, and DF all intersect at point B. Each of the statements is justified using a property, postulate, or definition. All right, so I'm going to switch back to my slides here real quick. Okay, so go ahead and look at example A on your paper. Try covering up the justification column. Let's go through them one by one. Okay, so here's an example A. So the first statement we have is that if angle ABE is a right angle, then angle ABE is equal to 90 degrees. So take a look over here. Yep, so it looks like ABE is a right angle, and we're saying if it was a right angle, then it would equal 90 degrees. Okay, well, why would that be? Okay, that's the answer that the justification is trying to answer there. So why is it that if it's a right angle, then it equals 90 degrees? Well, the answer is because that's the definition of a right angle. Okay, if we looked up definition of a right angle, if we looked it up in the dictionary, it would say a right angle is an angle that equals 90 degrees. Okay, so you can see what justification does is it basically references a person to the statement, the postulate, the definition that justifies why that statement is true. Okay, all right, let's try the next one out. It says if angle 2 is congruent to angle 1 and angle 1 is congruent to angle 5, then angle 2 is congruent to angle 5. So think through this one real quick, okay? So basically angle 2 and angle 1 are congruent, angle 5 and angle 1 are congruent. Congruent means the same, okay? So if they're both congruent to the same angle, they would have to be congruent to each other, right? Ah, and that's a little something that we call the transitive property. Okay, so you learned all those properties whenever we did the algebraic proofs. So you had like addition property, subtraction property, and then you had things like the symmetric property where you could flip it around. Well, one of the other ones you had was the transitive property, basically saying if two things are equal to the same thing, then they're equal to each other. Okay. All right, let's say we were given that B is the midpoint of AC and we wanted to prove that AB and BC are congruent. Well, if you think of that, that's the two halves, right? So that would be the definition of a midpoint. And then for part D, we have the measure of angle 2 plus the measure of angle ABE equals the measure of angle DBE. If I look at that up here, notice this is angle 2, this is angle ABE, and the whole thing is angle DBE. Do you remember what it was that we had where you could add the two angles up to equal the bigger one? Yep, very good. That was the angle addition postulate. All right, last but not least, if angle 1 is supplementary to angle FBG, so FBG is right here, angle 1 is right here, then measure of angle 1 plus the measure of angle FBG equals 180 degrees. Okay, so notice they started out by saying if it's supplementary, then they add up to 180 degrees. That would be the definition of what supplementary is. Okay, all right, so this gives you an idea of what statements and justification are. Go ahead and pause this video, okay, literally pause it right now. Take out your headphones and then do the try these A. So on your paper, scrolling down. So these ones right here, okay? Go ahead and try reading through these statements, filling in the justification, and then once you have that done, it'll probably take you 5 minutes or so. Turn the video back on and I will show you the answers. All right, so hopefully you went through and tried those on your own first. Go ahead and check your try these A. Okay. All right. Okay, so let's go ahead and check your understanding real quick. So the first one, explain why the following statement does not need to be justified. It says the midpoint of a segment is a point on the segment that divides it into two congruent segments. So as I read this statement, isn't this the definition of a midpoint? Yeah, and it's literally word for word the definition of a midpoint. If you look back in your notes when we first introduced the word midpoint, those are the words that we use to define it. Okay, so if a statement is already the definition, that would be more of a justification than a statement that would need to be justified. Okay, so just so you know, whenever we use the, words in a justification, like, definition of a midpoint, definition of supplementary, we're using that as basically a shorthand way to refer to the full statements of their definitions. We could actually put the full statement in there if we wanted to. Okay. All right, given that RS and ST share endpoint S, based on this information, Michaela says that the segment addition postulate justifies that RS plus ST equals RT. Is there a flaw in Michaela's reasoning, or is she correct? Explain. Well, at first glance, it seems like she would be doing okay with that, right? I mean, segment addition postulate, we add the two smaller pieces up to equal the whole. I want to give you one scenario there here, though. What if her segments actually meet at an angle like this? So this is RS, this is R, this is S, and this is T. So then would the segment addition postulate work? Yeah. Okay. So that's the one flaw with her reasoning. Otherwise, she's doing great because this is a statement that is justified by the segment addition postulate. Okay. All right. Write and justify two statements based on the information in the figure. So looking at this figure here. Okay. So take a couple moments and look at that. So when I look at it, I see a right angle here. Okay, so I think it would be reasonable to say that angle GFJ is a right angle, which means the equals 90 degrees, right? Ah, and what statement or what would justify that statement? It would be definition of a right angle, because we know if it's a right angle, then it equals 90 degrees. We could also say the measure of angle GFH plus the measure of angle HFJ equals 90 degrees, okay, if they're complementary. So that would be definition of complementary. We could also say angle GFH plus angle HFJ equals angle GFJ. That would be the angle addition postulate. So any of those would work. Okay, so there's a lot of justifications to keep track of. Basically, it's all of our definitions, postulates, and theorems. Okay, so in Google Classroom, there is an assignment, which I'm going to add in there. Okay, and it's called Geometry Acceptable Justification. Okay, go ahead and complete that. Basically, I have all of the statements filled in for you. I just need you to fill in the meaning column so that you know what it means when we say definition of a right angle, when we say definition of supplementary. Just a quick reference guide so you can remember what all of those are. Okay, once you are done with that, make sure you submit it, and then your homework tonight, the lesson 6-1 practice, which you could probably get done in class as well. All right, so work hard, email me with any questions, and have an absolutely lovely day.